So my name is Luigi Teola, faculty member from the University of the Philippines Electrical and Electronics Engineering Institute, and I'll be your host for today's morning program. So we are now at the second and last day of the National Electrical, Electronics, and Computer Engineering Conference, or NEECECON 2024, co-located with ASTICON 2024 here in Novotel, Manila, Araneta City. So before we start, we would like to take a moment to recognize the generous support of our NEECECON sponsors, Advanced Energy, Techmark Keysight Technologies, Embedded Silicon Technology Solutions Corporation, Meralco, Analog Devices Incorporated, Presidium PH Corporation, Road and Schwartz Philippines Incorporated, Alexan Commercial, Maker Lab, Samsung Electronics Philippines Corporation, and Challenge Systems Incorporated. For this morning, we will have several keynote speakers to talk about their extensive industry experience and some of the advancements their organizations have undertaken in recent years. Our first speaker today is a professional electrical engineer and currently the Vice President and Head of Meralco's Networks Technology Management. He is currently the chairman of the Association of the Electricity Supply Industry of East Asia and Western Pacific Technical Working Group on Smart Grid and Asset Management. He is also the incumbent president of the UP-EEE Alumni Association. His areas of expertise include electric distribution construction, operation, repair and maintenance, power system analysis, power quality, electric distribution process, research, technology and technical standards, and asset performance management. He plays a critical role in various technology and sustainability projects of Meralco, such as Advanced Distribution Management Systems, Enterprise Geographic Information System, Mobile Workforce Management System, Enterprise Asset Management, Data Historian, Smart Streetlight, Meter Data Management System, and Data Analytics Solutions. He holds a Bachelor of Science degree in Electrical Engineering from the Mapua Institute of Technology and a Master of Science in Electrical Engineering from the University of the Philippines. He also completed his Management Development Program from the Asian Institute of Management and the New Frontiers Middle Management Program. He is the Continuing Professional Development Manager and Innovation Champion for Meralco Networks Organization. Here today to talk about Meralco's smart grid journey, let's all give a warm round of applause for Mr. Jose Jojo Reyes Jr.
Thank you, Luigi. Good morning to all of you, participants of this first ever National Electrical, Electronics, and Computer Conference. I am Jojo Reyes again of Manila Electric Company, and it is but a privilege for me to share with you our journey to the grid of the future. That is, smart grid. Wherein the traditional electrical network is transformed to a robust, digitalized, and smarter grid. Most of us resides in the metro and served by Meralco. But please let me reintroduce to you Meralco or Manila Electric Company. Well, it used to be called Manila Electric and Railway Company. As a distribution utility, we serve the franchise, which is a seat of economic, political, and social activity in the country. 111 cities and municipalities are inside this franchise area. And we have grown to serving around 7.8 million customers, roughly around 25% of the country's population, and we comprise around 55% of the country's electricity consumption. Okay. According to the International Energy Outlook, the world's energy system has drastically changed because of new energy policies moving towards clean energy, our worries about energy security and population growth. The energy industry identifies four key areas: decarbonization, decentralization, digitalization, and democratization as drivers. The focus is basically improving technology, in all energy sectors using storage systems better, embracing the Internet of Things, partner with artificial intelligence, machine learning, and adopting new technologies to speed up the shift towards a cleaner energy. The slide shows our traditional electric system, whereby there's basically one flow from generation, transmission, distribution, up to consumption of electricity. For almost 100 years, almost all of us are served where these electrons make their way to our light bulbs. No frills, no thrills. I now summarize the rationale for Meralco to come up with its own technology strategy and roadmap to address both internal and external factors being faced. These are the 8 cases for change wherein basically there is increase in the renewable or distributed energy resources penetration. And I guess most of us have their own solar PVs. Stronger typhoon and other natural calamities. We know that Philippines has been visited by an average of 20 typhoons annually. Well, it took us more than 30 minutes before we get here because of the worsening traffic situation in both urban and rural areas, even though the company is a stone throw away from this location. And as a customer myself, we have an increasing demands and expectation. Being high-tech, we should know every inch of the detail of our service, the service being provided to us. And then the rapid digitalization and evolution of data analytics. This year is a year of AI. You don't know if the person who's talking to you is a real person. And there's an evolving power industry policies and regulation. It used to be just the cost and the basic requirements of the regulator, but now it's different. And as we experienced during the pandemic, we have to be resilient. We should be able to read the meters even there's a pandemic. And finally, we should future-proof, of course, the distribution network. And this is what the solution is, smart grid. The smart grid basically is an electricity network system that uses digital technology to monitor and manage to transport these electrons from the generation sources to meet the varying electricity demands and services, dulo, end users. Such grid can coordinate the needs and capabilities of all the generators, the grid operators, and capabilities of all all electricity market stakeholders. It should optimize the use of asset, operation, and in the process, minimize both cost and environmental impact. Not only operating it efficiently, but one of the more important thing is to minimize or even eradicate the environmental impact while maintaining resiliency, reliability, and grid stability. Meralco's Smart Grid program communicates the delivery of our Smart Grid vision. There are 5 strategic themes that we established to accomplish the Smart Grid vision, namely grid efficiency, reliability, and resiliency, advanced asset management, distributed energy resource integration, safety and work efficiency, and the more important, customer empowerment. I have 2 twin sisters. First one is Anna and Ami. Well, basically, those are the 2 pillars of the smart grid. Anna for the advanced network automation, and AMI or AMI for the advanced metering infrastructure. These transform the network backbone to become what we need in terms of resiliency, integration, and high efficiency. Digital technology will definitely integrate the electricity and communication networks into what we call the energy web, capable of supporting a new wave of interactive energy and information systems and services and supplying digitally enabled and quality power for all types of customers. It will supplement the existing electricity network with the state-of-the-art sensors and communications over the coming years through smart power system technology. Anna and Ami live harmoniously and complement each other toward the goal of an automated, smarter grid. Let's start with Anna, the elder one. We began our journey, basically, way back in 1994, when Meralco started the substation automation through SCADA. So shown in the slide is our conventional substation, those A-frames, the huge switchyard, wherein we converted it to GIS substation. Usually we required around 3,000 square meters of lot, but now it's less than 1,000. And we're aiming for almost a very small lot of 500 square meter, and further looking into underground substations. Meralco substations are basically unmanned, hence, we really need to monitor all aspects of the operations of these substations. We are continuously modernizing this substation and had considered the implementation of this widely used IEC 61850 communication standards for substation. It is an international standards defining the protocol for intelligent electronic devices. And it is a part of the IEC Technical Committee number 57, Reference Architecture for Electric Power Systems. Hence, it enables the integration of all protection, control, measurement, and monitoring functions within the substation and provide the means for high-speed protection application, interlocking, and intertripping. Today, Meralco has 16 existing smart substations, and by 2028, it will grow to around 40 smart substations. Shown in the slide is a typical, what we call the old substation automation solution, comprising of several analog interfaces, though some secondary devices are microprocessor-based. All components of the substation, from the high voltage switchgears, power transformers, and medium voltage switchgears are wired, copper wired, to various secondary devices like relay, controllers, meters, and condition monitors. Now using or implementing the latest standard of IEC 61850, the data across these devices are being sent to the network in the digital format, which will enable the functions like local and remote monitoring and control and even protection. The newest technology that we are looking at right now is what we call the virtual relay and the virtual substation. It's in the works right now, and perhaps we can utilize that or implement that in coming years. The next aspect of automation is for the distribution line. 97% of Meralco's distribution system are overhead lines, thus exposed to the elements and are subject to challenges of vehicular accident, animal intrusions, lightning, and occasionally equipment failures due to age. Knowing where these problems occurred and having the ability to isolate the affected portion of the lines is the basic deliverables of a distribution automation system. To be able to accomplish that, Meralco started replacing many of the conventional and manually operated line switches with remotely controlled automatic circuit reclosers and other field devices starting the year 2000. So basically, this is the year where Meralco started adopting the remote control, the equipment, especially the switches, the voltage regulators, and also the line capacitors. Because prior to that year, way back 1990, we were able to control already our substation breakers, but not the field equipment or field devices. Coupled by the communication system, we were able to monitor and control these devices through the platforms or the back-end system, the SCADA, and the ADMS. And by 2028, we will be having around 5,700 remote-controlled field devices, which includes, as I've mentioned, remote-controlled line switches, remote-controlled line reclosers, remote-controlled line capacitors, step voltage regulators, DT monitoring equipment, and voltage circuit indicators. So the DD monitoring equipment, sometimes we call that DTME. It will grow around 12,000 by 2028. Substation automation and distribution automation are supported by two major back-end OT or operational technology systems, namely, as I mentioned earlier, SCADA and ADMS. SCADA is our heart of the control system. This is highly secured installation and have backup systems somewhere in the franchise area of Meralco. It is responsible for aggregating all the data and measurements of the substation and the distribution lines so that our operators can monitor them and respond for any incident at the quickest time possible. It is very much reliable at 99.9997%, and as it must operate 24/7 without failure. In tandem with SCADA, we have this ADMS. If we consider SCADA as the heart, ADMS is the brain. ADMS consists mainly of two systems, the outage management system and distribution management system. So whenever you call the call center of Meralco, your call will be forwarded to our operators manning the ADMS so that they can immediately dispatch our crews. And of course, we can also, through ADMS, we can simulate the load flow, the fault magnitude, and we can easily identify the location of the fault anywhere in the distribution lines. And we can also accurately predict or know what we call the prediction of if the trouble is caused by a simple wire down on the service trap, an outage of a distribution transformer, or even an outage upon the entire distribution line. So that is how the ADMS operates. And it is the availability is 99.59%. Now, Meralco combines these two systems, SCADA plus ADMS. It is a unified operations platform, and it has an advanced OT security, those listening ears, wherein it logs every tick or click of the keyboard. So the system knows how many clicks, how many logins, and where the data goes. It is also there aware. That means it knows the various electrical parameters anywhere in the system, thereby readying itself for the next generation of ADMS with DERMS. DERMS means Distribution Energy Resource Management System, which we will implement in 2027. It has flexible reporting tools and web dispatching capability. There are advanced applications of the ADMS, what we call the self-healing, to make the grid self-healing. First is FLISIR, wherein we call it the fault location, isolation, and service restoration, wherein all the devices, the recloser, the line switches, are automatically reconfigured in response to an unplanned outage. It is a centralized approach through SCADA, ADMS, wherein it automatically isolates and reconfigures segments of the distribution feeders using sensors, control switches, and robust communication system. On the other hand, IBVO, or the Integrated Voltbar Optimization, also an application in ADMS, determines the best set of coordinated control actions, let's say, what top and how many line capacitors or even substation capacitors should be in or out. The objective is to minimize loss and manages voltages within acceptable range at all points of the feeder and at all loading condition. It can also be used in an advanced stage of reducing system demand, although we haven't tried this yet, through voltage conservation without sacrificing the regulated service level. Aside from ADMS, there are various OT and IT systems and applications that complement or support them. Like the enterprise asset management, this is the basically the work order management system of Meralco, wherein it is responsible for dispatch of the work order execution of the field crews. Those are our crews with the basket truck and the stake truck. So they have this EAM. And also, we have the enterprise-grade geographic information system. These two complement each other to determine the exact location, the historical, basically tracking the asset life from what we call from boom to tomb. Boom means during the SCM or supply contract and up to tomb, wherein we can dispose the asset. So it also complemented with what we call the data historian. Actually, this data historian platform serves as the main backhaul of data, wherein there are millions of sensors installed in the distribution lines. The data historian holds this data to the centralized server, wherein we can perform data analytics through what we call the Meralco data platform. We have also in our mobile workforce management system. So you may notice that our crews have their own tablets, and we can easily determine their location. We can also determine what point in time the work order is being executed and the adequacy of the materials that crew or particular truck has. And ongoing right now is the protection management system. Basically, it is a platform that can control, configure all brands and types of relays. And finally, for ANA, our ADMS2 is there aware, as I mentioned. And the objective for this is to basically allow the distributed energy resources, not capping them, and enable DER to provide grid support and facilitate the customer participation in the energy market. We now turn to the younger sister, AMI. Well, the role of electronics and computerization have been very instrumental in the development in the energy sector. We accelerate the adoption of many technologies, and one of the important products of the convergence of the semiconductor, communication, and IT technologies is advanced metering infrastructure. The basic function of our AMI is basically remote meter reading, data analytics, remote connection and disconnection, and detection of irregularities in the electricity. Emerging technologies such as data analytics and machine learning are used to forecast demand or detect anomalies in service. You know, most of the meters right now are turning themselves into edge devices wherein they have their own forms of AI or intelligence. They can decide by themselves, and we are looking into that. Right now, our intelligence is on the back-end system, but soon we'll try to adopt these edge devices. Because this sensor help also in the reliability of the grid, wherein our customer would not call Meralco, but the smart meters will call Meralco, telling if there's a disturbance, if there's an outage in the customers. Thereby, we can easily send our crew. In the coming years, Meralco continue to depend on the semiconductor and electronic industries for various sustainable solutions, such as the batteries, panels, etc. Our other major initiatives are supporting the overall target of the government in increasing the amount of renewable in the energy mix. We consider the critical role of the application of the battery energy storage system. We have a 2 megawatt pilot project in San Rafael, Bulacan, and we have an existing 1.4 megawatt solar microgrid in Calbalete, Mauban, Quezon. And of course, in greening the supply portfolio, We complied with the DOE-mandated renewable portfolio standard by sourcing from RE power supply. For the energy storage system, we also have the flywheel energy storage in our main headquarters. And we have a project still on pilot and RFP stage, the pole-mounted BESS and the mobile BESS. Despite these advanced technologies, Meralco recognizes the need to retool our manpower resources to be able to execute and make full use of these technologies, thus the birth of PowerTech. PowerTech stemmed from the minds of Meralco employees themselves. It is the product of an action learning program in 2014 made into reality. I'm proud to be part of the Meralco, what we call the New Frontier program, in which one of the project sponsored or being made into reality is the PowerTech. It is a training and R&D center which aims to fast-track learning and adoption of ongoing and future smart grid initiatives of the company. It is composed of 9 laboratories. The control center, which is the heart of the smart grid. We also have the distribution automation or the distribution yard, the smart substation, microgrids. We have a microgrid setup. We have the asset diagnostic, those tools and work equipment that are displayed outside. We also have that. The advanced metering infrastructure, EV charging station, smart home, and Fixel or our experiential laboratory. Basically, we mimic or we put into a building all of the smart grid initiatives or projects of Meralco. The latest of which here is the Pixel, wherein we implement what we call the digital twin. You don't have to go to the field to monitor, to troubleshoot the actual field equipment. Just be inside Pixel and you can implement maintenance work there. A key objective of the smart grid strategy is to basically to provide reliable and high quality power by leveraging technological advances to keep the lights on for our 7.8 million customers. It also supports our national government policy objectives that may not provide immediate direct customer value but may provide broader benefits to communities over time. The smart grid value proposition presents a portfolio of investment on technology initiatives to modernize the grid capability. The overall smart grid benefits are customer, utility benefits, and community. Let us make the grid smarter, enhancing efficiency, reliability, and sustainability. As we in Meralco, in the service company, we are with you by keeping the lights on for our customer. Thank you for your attention. Good morning.
Thank you very much, Sir Jojo. We're now opening the floor to questions from our audience. There's a microphone at the center of the ballroom. So if you have any questions, please approach the mic.
Hi, good morning po. Earl Wanico from UP Diliman AI program. Thank you for the talk. No? I'm quite interested in the alignment kasi of the move towards sustainable, greener energy sources with the digital transformation, because we are aware that to be able to, let's say, integrate AI into the system, you'd actually need a lot of computing power, yes, which entails a lot of energy capacity. So how does that align? Because if we're going to like move to lesser coal power and all these non-renewables and fossil fuel driven energy, in the transformation, how is it aligned with a greener energy source, yung digital transformation? I just want to see that from your experience.
Yeah, actually, I have a slide there, but I did not put. But Meralco has this program we call Greening the Networks, which is basically aligned with the smart grid transformation initiative of the company. Greening the network entails the entire spectrum of distribution operations, wherein we first look at the hardware. Let's say, for example, the breakers. We use non-SF6 or what we call SF6 free breakers, reclosers. So we're going into that. The GIS, actually the GIS is SF6 insulated. We now have what we call, or we are in the process of piloting what we call the SF6 free. We do away with the SF6 for our gas insulated switch gears. For our distribution and power transformers, for the distribution transformers, all of our new distribution transformers are insulated with the natural ester oil. We have now a project for a power transformer in Pasig. In one of our sector offices there, the use of a ester oil for an 83 MVA power transformer. And also, we're looking on the, as you noticed, we implement microgrid using PBs and also battery energy storage. We only use genset as backup because somehow, since that is in the island, we cannot completely do away but only serve that as a backup. And one ADMS per se, we initiate merging SCADA and what we call the OMS and DMS into one, specifically to allow renewable penetration. Because we know that renewables have this intermittency. Now you see them, now you don't, something like that. No? So the ADMS is basically designed to handle that. At this point in time, it is only aware. But on 2027, wherein we are expecting before the turn of, by 2030, 35% of the energy portfolio is coming from the renewable. So the system should be able to handle that. Another initiative is that we're looking into being a distribution system operator in the distribution grid, because we know that grid operators are basically on the transmission side. So those are some initiatives, and also we have this what we call the Terra Solar Power Project in Nueva Ecija. That's around 3.5 gigawatt of capacity. So basically, the Meralco is doing everything to have this the grid smarter, to address the RE. Basically, that's the driver, RE. We must have the grid smarter by putting those IoT devices. And in so doing, we have lots of data. And we need computing power, we need artificial intelligence to do that. For us, in the utility sector, to decide on what operationally best for our customers. So it's a matrix, it's a combination, it's quite complicated, but I believe in terms of collaboration with the government, with the regulators, and of course with the academe, we can all do it, just like in the North and in Europe, wherein in Germany it's almost 100% RE. So many of them are solar. And mind you, we are encouraging all of our customers to use solar or to install solar PV. No, we just have to comply with the regulations of our ERC to have that. But it is very much welcome.
We have our own strategy then, sir, right?
We have our own solar company also. Mm-hmm. Yeah.
I see.
So that's it.
One last na lang, sorry. Because there's probably a possible increase in the take-up of electrical vehicles. So there's a wide electrification of the vehicular system, especially sa Metro Manila, where Meralco is, well, a dominant distributor. So how do you see the digital transformation also come into play with probably more EVs, maybe 10 years or 20 years down the line? Because that will also entail a lot of computational, aspects. Because
right.
EVs will have their own onboard computers, basically.
There are so many technologies that we can look into. Actually, our ADMS is ready for that. That is what we call the DE, or they're aware, because PB or the chargers basically can act as a load and a source. So we are readying that for the what we call the vehicle to grid, wherein depending on the needs of the grid, it can act or it can sell electricity. The only thing that we need to establish right now is regulation. The technology is there. It's been there. Even we also there is also a concept of the virtual power plant, wherein all of us all of us residences that have PV solar rooftop can also sell to the market operator. But we only need to advocate for regulation, how it should be done. Right now, during the red alert and yellow alert, it's been very crude that we are calling our large customers to participate in the what we call the interruptible load program, wherein to save the grid, they have to be cut off. They voluntarily cut off from the grid and use their generators. Unfortunately, the generators are diesel fuel fed. And then, we have to manually cut them off from the system. That is one of the function again of DERMS, wherein it's automatic, it's smart, it knows when. We don't have to call them 1 or 2 hours prior to the actual loss or deficiency of the grid. So that's why we really need to implement a comprehensive smart grid program for the country, not only for Meralco, because it will really help us. The technology is there, and there's a solution. The only thing that we need, of course, is collaboration and, of course, the regulation. Yeah, that's it.
Thank you, sir, and more power to that.
Thank you.
Thank you very much. Again, thank you for gracing us with your time, Sir Jojo. Now, may we call on the director of the UP Electrical and Electronics Engineering Institute, Dr. Lou Andrutria, on stage to hand our certificate of appreciation and token to Sir Jojo as our first keynote speaker for today. Again, another warm round of applause for our Mr. Jojo Reyes.